Hello everyone, in today's video, we are going to discuss about double integrals. In double integral, we are going to consider determining the integral of a certain function in terms of dy. So in doing this, we shall have 2x times y plus y to the third over 3 plus c times or attach the variable x, okay? So in here, if it's dy, just take a look at your y variable and integrate it. And then attach your y in your x variable. So since this is an indefinite integral, we are going to attach plus c and then attach x. Now, in terms of dx, what we need to do here is to concentrate on our x variable. We are going to integrate x, which is equal to x squared over 2. Then since there is a constant, just write the constant over there. And then attach the variable x in your y variable, which is y squared. And then since it is an indefinite integral, so plus c and then attach y. And then we are going to simplify. We can cancel 2 and 2. So the final answer will be x squared plus y squared x plus c of y. So these are the basics in order for us to integrate properly using the double integral. So let us have the double integral of x, y plus x squared y to the third dy from 0 to 2 as well as dx from 1 to 3. In doing this, the first step is to get the integral of the inner part. So the integral is xy squared over 2 plus x squared times y to the fourth over 4 from y equals 0 to y equals 2. Why I am writing y equals 0 and y equals 2 in order for you not to be confused in which variable you need to substitute. So concentrate in your y. So we will be going to have x times 2 squared over 2 plus x squared times 2 to the fourth over 4. Simplifying further, we shall have 2x plus 4x squared. And then this one, we are going to substitute it. So we shall have the integral of 2x plus 4x squared dx from 1 to 3. So we are going to integrate this one in terms of dx. So we shall have 2x squared over 2 plus 4x to the third over 3. We can simplify this one by canceling 2 in the numerator as well as in the denominator because it is equal to 1 already. And then we shall substitute the upper limit first before your lower limit. So we will be getting 3 squared plus 4 times 3 to the third over 3 minus 1 squared plus 4 times 1 to the third over 3. Simplifying further, we shall have 9 plus 4 times 9 times 3. So that we can cancel 3 in the numerator as well as in the denominator. And then we shall have 9 plus 36 minus 7 over 3 because 1 plus 4 over 3 is equal to 7 over 3. So we shall have 36 plus 9 is 45. So we will be getting 128 over 3. So 45 minus 7 over 3 equals 128 over 3. Now let us have another one. We are going to have the double integral of 2xy dy from square root of x to 1 plus x dx from 1 to 3. So we start from the inside going outside. So let us have the integral of 2xy dy from square root of x to 1 plus x. It is equal to 2x y squared over 2 from y equals square root of x, y equals 1 plus x. I cancel 2 already, it will be equal to 1. So simplifying further, we will be getting xy squared from y equals square root of x to y equals 1 plus x. Then we are going to substitute the upper limit first before your lower limit, and then we are going to subtract. So we will be getting x times x 1 plus x squared minus x times square root of x to the power of 2. We can cancel the square root symbol as well as to the power of 2. So it will become x squared. And then 1 plus x times 1 plus x multiplying binomials, it is equal to x squared plus 2x plus 1. Then you are going to distribute inside the parenthesis. It will be equal to x to the third plus 2x squared plus x minus x. Simplifying further, 2x squared minus x squared will be equal to x squared. So we shall have x to the third plus x squared plus x. Now we are going to substitute there. So we shall have the integral of x to the third plus x squared plus x dx from 0 to 1. So in integrating this one, we shall have x to the fourth over 4 plus x to the third over 3 plus x squared over 2 from 0 to 1. Since we have the lower limit which is equal to 0, need not to subtract it anymore. Instead, we are going to substitute 1. So in substituting 1, we shall have 1/4 plus 1/3 plus 1/2, which is equal to 13 over 12. So let us have another one. Let us determine the double integral of xy squared dy from 1 to 3 dx from 0 to 2. So the first thing we need to do here is to determine the integral of xy squared dy from 1 to 3. So it is equal to xy to the third over 3, or it can be written as x over 3 times y to the third power from y equals 1 to y equals 3. And then we are going to substitute the upper limit first before the lower limit. So we shall have x over 3 times 3 to the third minus 1 to the third. 3 to the third is equal to 27 minus 1 is equal to 26. So therefore, we shall have 26 over 3x. Then we are going to determine the antiderivative of 26 over 3x from 0 to 2 dx. From here, it is equal to 26 over 3 times the integral of x, which is equal to x squared over 2 from 0 to 2, which is equal to, when we simplify it, we can cancel 26 and 2. 26 will become 13 and 2 will become 1. So it is equal to 13 over 3 x squared from 0 to 2. Then we are going to substitute our upper limit first before the lower limit. So we shall have 13 over 3 times 2 squared minus 0 squared. 2 squared is equal to 4. So we shall have 13 over 3 times 4, which is equal to 52 over 3. So let us have our last example. In our last example, we are going to have the integral of dx first before our dy, since it is inside. So to determine the integral of this one, it is equal to 2yx minus 3y squared times x to the third over 3. Then we can cancel 3 and 3. It will become 1. Integrate from x equals 0 to x equals 1. So from here, we are going to substitute x equals 1 since we already have the lower limit as 0. In doing this, so we shall have 2y times 1 minus y squared times 1 to the third, which is simply equal to 2y minus y squared. Then we shall have the integral of 2y minus y squared dy from 0 to 2. So in integrating this one, it is equal to 2y squared over 2 minus y to the third over 3. We can cancel 2 in the numerator as well as in the denominator. It will become 1. Simplifying further, we shall have y squared minus y to the third over 3 from 0 to 2. Since we have the lower limit which is equal to 0, so no need to substitute for that. So we shall have 2 squared minus 2 to the third over 3, which is equal to 4 minus 8 over 3. And 4 minus 8 over 3, it is equal to 4 thirds. So that's it for now. Thank you for watching. See you again next time. Bye.